Okay, continuation of sketching parabolas by completing the square. So there's a couple of examples here where you're required to sketch the graphs by completing the square. So given you'll find x-intercepts, it's asked for exact form, so it should probably have a surd in it. And so if you get the two x-intercepts, if there is two, and the y-intercept, you can draw a graph. Okay, so here you have to use your skills to complete the square. Okay, so let's go and do the first one here. Okay, so let's rewrite this, and if you remember, complete the square, what we do is we have a spot, have another spot, leave another spot, and then we write the other thing in there. So if you remember correctly, to complete the square, what we do is we take this number here, we divide it by 2, and we square it, and we add it to the end. Okay, so 6 divided by 2 is 3, 3 squared is 9. Alright, so what we do in the next step is plus 6x, so plus 9, then we have to take away 9 and add 15. Okay, so actually, this bit here is now a perfect square. Okay, and if you remember correctly, that will be x plus 3 all squared. Well, negative 9 plus 15 is going to be, what's that going to be? Positive 6. Is that right? Positive 6. 6. Okay. Now, what you should notice by this is this is not a difference of perfect squares. Okay, so what that means is, it doesn't mean that it doesn't exist. It means that it doesn't have any x-intercepts. Okay, so it sort of hovers above the x axis. All right. What we can find is the turning point now. Now that we have we've completed the square, this number here and this number here tells us our turning point. Okay, so our turning point TP is equal to, remember, this will be a negative of that, and 6. Okay, so that's our turning point. Okay, our y-intercept occurs when we let x equal 0. Okay, so we can go back to our original equation, and if you remember correctly, because there's all got x's in them, our y value is going to end up being that constant on the end. Okay, so that's our y-intercept there. Alright, so let's put all that information on a graph and see what this one looks like. Okay, so we have no x-intercept, so it has to be above here somewhere. I'm going to put y equals 15 up here. Okay, my turning point is at negative 3, which would be here somewhere, and positive 6. So 6, negative 3, my turning point is going to be here. Okay, so you should, what other information do we need? That was it. Okay, we know that this will, using this information, we know it goes through here and here. With only 2 points, you can't actually tell what it looks like, because it could look like this. Oh no, it has to turn there. Okay, so it has to be this. Okay, so that's my apologies for that parabola. It's a bit hard to write on this touch screen, so that's what our graph of that one will look like. Okay, so it's quite an easy one. Alright, so let's go on to this next one here. Actually, by the way, sorry, you should actually write negative 3, 6 as a turning point there. Okay, this second one is a little bit trickier. Okay, so we're going to complete the square again. And so again, we leave ourselves some room and more room. Okay, and we complete the square. So you divide negative 3 by 2, which is negative 3 on 2, and then you square it. So we're actually going to get negative 3 on 2 all squared. So we add that on, and then we take it away. Okay, minus 1. Alright, so I'm not going to bother working this out because this becomes our perfect square. This is our perfect square. So, if you remember correctly, it's going to be this number in here. So, x minus 3 on 2 all squared. Okay, that's how that works, because it's the number here is either going to be this divided by 2 or this square rooted, because that's how we made it. Okay, let's work through this thing on the end we have to add on or take away in this case. So we're minusing, now negative 3 all squared is going to be, it's going to be a positive number. It's going to be 9 on 4. Okay, and it's negative because we have to take it away, remember? And we minus 1 on the end there. So let's just work that out. Okay, now negative 9, 9 over 4 take away 1. 1 expressed as 4s is actually going to be 4 over 4, isn't it? Okay, so if we have 9 fourths and we take away 4 fourths, how many fourths have we got? Well, negative 9 fourths take away 4 is going to be negative 13 fourths. Okay, so that's a completed square version of that equation. Okay, so that would give us a turning point. All right, so our turning point now, turning point is equal to the negative of this, remember? The negative of this is actually 3 over 2, and this value here, which is negative 3 over 4. Okay, the second part of this is the x-intercepts. So for the x-intercepts, we let y equal 0. Okay, so we've already completed the square here, so I'm going to use that version down there. I'm going to rewrite that. I'm actually going to use this here, and I'm going to put it up here. Okay, so y equals x minus 3 on 2 all squared minus 13 over 4. Now, this is where it gets a little bit tricky. We're going to make that equal to 0. I might actually take that up. Oops. Let's get rid of that. And we're going to factorize it, okay, to find out our x-intercepts. So to do that, we remember when it's not a square number here, we need to take a square root of a square number. Okay, so let's rewrite that, x minus 3 on 2 over 2. Now, if you look carefully here, the 13 is not a square number, but 4 is, so I can square root 4. So I'm going to get root 13 on 2 all squared. Okay, so that's my 2 square numbers now. So I can use factorize using a DOPS. This is a DOPS. So x minus 3 on 2 minus 13, root 13 on 2, x minus 3 on 2 plus root 13 on 2 equals 0. Okay, so they're the two things I solve. So with this one, I solve this for 0, and I'll solve this one for 0 as well. I'll do it step by step. Okay, so I'm going to move both of these. I'll do it on one step. So I'm going to move both of these over to the other side. So they both become positive because I have to add it to both sides. We get 3 on 2 plus root 13 on 2. And on this one, same again, I'm moving this over, which will become positive, and I'll move this one over, which will become negative. Okay, so that's going to be x, that should be equal to 0. So x is equal to 3 over 2 minus root 13 on 2. Okay, now, these aren't quite finished. So see, this is, see we've got surds here. Okay, so this is in exact form. Okay, so let's combine those because they've both got a common denominator, we can put them over the same thing. So we actually get 3 plus root 13 over 2, and it will be 3 minus root 13 over 2. Okay, so let me just check that. Okay, so that's how you find the x-intercepts. To find out where approximately they are on the x-axis, you can stick that in your calculator. I've done it in advance, so I'll work it out. Just one more thing. We'll work out the y-intercept just quickly over here. Hopefully, by now you can see that the y-intercept will be the constant in this, so that'll be -1. Because if I put 0, x equals 0, everything else will end up being 0, so the y-intercept is going to be -1. And we put all this together in a graph, okay, which was the idea. Alright, so let's just draw a nice set of axes here. Now, if you do put these in your calculator, so the negative, this one here ends up being about here somewhere, and the positive version ends up being over here somewhere. Okay, they're about equal to that. Might be a bit tricky to write. Hang on, I will write it. That's those points there. Okay, our y-intercept was -1, and our turning point was at 3/2, -13/4. So 3/2 is about 1.5, which is, well, it's exactly 1.5, which is just here, and -13/4. Okay, so turning point is here. So the way that would look, it's not quite on that scale, but it will sort of look a bit like this, going through there, turning there, and going up through there. Okay, so that turning point is 3/2, -13/4. Okay, so that is how you sketch parabolas by completing the square.